Okay, so today we're going to learn how to write ionic compounds. And these are the charges of the ions that are located on the back of your periodic table sheet that either you've had for a couple months or you just picked up today. As we've learned before, there are two types of ions. There are cations and anions. The cations are the positively charged ions, and the anions are the negatively charged ions. And this sheet has them grouped into the charges they form. So all of these cations form a +1 charge. All of these form a +2 charge. And then we have +3s and +4s, along with the anions and -1, -2, 3, and 4. And what we're going to do is we're going to learn to combine a cation and an anion and write the proper chemical formula by canceling out their units. So I'd like you to look at the first sheet that you have in your packet. Looks like this. Okay. And then also make sure that you have your ion sheet available to you. So what we're doing when we write ionic formulas is we write the cation first and then the anion. Always cation first, then the anion. We look at the charges of the two ions that combine, and the goal is to balance those charges so that when they're combined they have a net charge of 0. So if we look at the two examples that are done for us, calcium has a +2 charge. Sometimes you'll see it written like this, 2 plus, sometimes +2. It does not make a difference. They're both the same. How do we know calcium's a +2 charge? Because we look at our, well, number one, it tells us there, but number two, we can look at our sheet, which you will always have available to use on a quiz or a test or homework, and we can see calcium is in the +2 column. So we know calcium's a +2 charge. And then the chloride ion is a -1 charge. And again, we know that because we can look on our sheet, or it tells us here that chloride is a -1 charge. So what we need to do is balance our charges so they equal 0. And if we write the charges out here, we'll see calcium's a +2 and chlorine's a -1. So what we have to determine is how many -1s we need to add in order to get 0. If we want the charges to equal 0, well, +2 -1 -1 equals 0. So that tells us we're going to need two -1 charges, or two chloride ions, to balance the one calcium ion. So we're going to need one calcium, or 1 + 2 charge, and two chloride ions. So the way that we write that then is to write the symbol for the cation, Ca, write the symbol for the anion, Cl, and we're going to indicate the number of ions needed as a subscript. And that's why we have that 2 written down there. So that tells me I have two chloride ions, each one with a -1 charge, and one calcium ion, each with a +2 charge. So we have a +2, -1, -1 equals 0. And these two -1s just come from the two chloride ions. And then to write the name of the formula, we simply write the cation name and then the anion name. So this is calcium chloride. If we look at the second example, you have calcium again, +2. Then we have this NO3 ion. This is called the nitrate ion. And if you look on your charges of common ion sheet, you'll see that's called the nitrate ion. Nitrate has a -1 charge. So it's really the same game as what we did with the calcium chloride. We're going to need one cation and two anions. So we're going to write the chemical formula as Ca, and then notice that the NO3 is in parentheses. This is a polyatomic ion. It's an ion made up of more than one atom. And whenever we have more than one of those polyatomic ions, we need to put them in parentheses and then put the number of ions that we have on the outside of the parentheses. So we can show that we have two of these whole things. And that's this rule written right up here. If we need more than one polyatomic ion, then we need to write the subscript outside of parentheses. And there are a number of anions that are polyatomic. There's really only one cation that's polyatomic, and that's the ammonium ion. Actually, there's two, the hydronium ion as well, both +1 charges. Okay. Okay. So let's look at a couple of these examples here that we're going to do together. We'll look at the sodium chloride. Sodium has a +1 charge. Chloride has a -1 charge. So if we have a +1 and a -1, those already balance out. They equal 0. So we're simply going to need one sodium and one chloride. So we can write the formula NaCl. We do not write a 1 as a subscript. By writing down the chemical symbol, we're saying we do have one of those. So then this would be sodium chloride. And again, to find the names of the ions, I'm simply looking on my ion sheet, finding sodium right there, finding chloride right there, and writing those down. Let's look at one down here, this sodium and this PO4, this phosphate ion. Now sodium has a +1 and phosphate has a -3. So in order to cancel out the -3, I'm going to need 3 +1 charges. Because +1 +1 +1 -3 is equal to 0. So I'm going to need 3 sodiums, 3 of the cations, and only 1 of the phosphates. So that I have 3 sodiums. So I'm going to write sodium. I'm going to need 3 of those. Then I need 1 phosphate. The phosphate ion is PO4. So let's go write those down. And I do not need parentheses on that because there's only 1 of them. So I can just write the symbol. And then the name, sodium phosphate. And again, I'm using this sheet here, which hopefully you have right beside you. And I'm looking at the PO4 right here is phosphate. So that's how I know the name of that. And please be careful, because there's a phosphate, there's a phosphite, there's a phosphide, just some different endings, and they're all different ions. Let me show you one little trick. This one that we just did, the sodium phosphate. This is called the crossover method. And what we do is we look at the charge. So the charge on sodium is a +1. I'm going to write a 1 right there so you can see that. Charge on the phosphate is a -3. What we can do to check our answer is to take the charge and cross it over so it becomes the subscript of the other ion. So a 3 becomes a subscript for sodium, and a 1 is a subscript for phosphate, which was what we've written down here in our formula. If we go back to this one that we did up here, the calcium, if we take the charge on the calcium, cross it over to the subscript of the chlorine, take the -1 charge on the chlorine and cross it over to the subscript on the calcium, that's what we had written down for our formula. Some people, when they're liking to write formulas, they like to balance the charges. Other people like to cross the charges to become subscripts. Either way you learn to write it is perfectly good, because we just want to get you to write these correctly. Let's look at another example on this page. Let's do this one here, the NH4+ and SO4 2-. This is called the ammonium ion, has a +1 charge. You can find that on your sheet. And this is the sulfate ion with a -2 charge. So I know that I'm going to need 2 +1s in order to balance out this -2, in order to get them to equal 0. If I look at the crossover method, if I take this number, this 1 is going to become the subscript on the sulfate. This 2 is going to become the subscript on my ammonium ion. So I'm going to need 2 of the cations and 1 of the sulfate. So I'm going to write this, NH4, and it's going to need to go in parentheses because I have more than one of them, and it's a polyatomic ion. And then I can write the sulfate outside. The sulfate does not need any subscripts, only the 4, because that's part of the ion. So then this is named ammonium sulfate. The goal is to balance our charges. I'd like you to look on the back side of this worksheet. And before we get there, if you could look at your common ion sheet, you'll notice some of the cations have Roman numerals written after them. That's because these are cations that form more than one charge. Like if you look at nickel, nickel up here forms a +1 charge. It also forms a +2 charge. Iron forms a +2 and a +3. Chromium forms a +2 and a +3. Lead forms a +2 and a +4 charge. So those Roman numerals identify for us which ion it is and what charge they have. And whenever you see a Roman numeral written here next to a cation, you must include it in the name of that cation. If you don't see a Roman numeral listed, you don't have to write it in the name. If you do see a Roman numeral listed, you have to write it in the name. All of the ones that we've done up to now do not have those Roman numerals. But that'll change here in just a moment. Let's look at tin phosphate down here, all the way at the bottom, the tin phosphate one. Tin has a +4 charge, and phosphate has a -3 charge. Now the common denominator between 4 and 3 is 12. So that means we want to get a charge of 12 on both sides. So in order to get 12, I need 3 +4s. And in order to get 12 with 3s, I need, oops, that should be a 4. I need 4 minus 3s to get those to equal 0. The other way to look at this, take the charge, make it the subscript. Take this 3, make it the subscript on the tin. So that I need 3 cations and 4 anions. So my formula is going to be SN3, and then PO4 is going to have to go in parentheses because I have more than one of them. 4. The name of this ion, or the name of this compound, is tin 4 phosphate. And I have to put that 4 in there because if you look up tin on your ion sheet, there are Roman numerals after it. And we know it's the tin 4 because we have tin with a +4 charge given to us, as opposed to the tin 2. If we have a situation where we have 2 charges that cancel out, like this one on tin 4 oxide, we have a +4 and we have a -2. So in order to get 0, I need 2 -2s. Make sure your subscripts are the lowest factor, meaning that we can't just cross these and make a 4 and a 2 because those can be reduced to a 2 and a 1. So when we write the subscripts, and so I'm going to need 1 tin and 2 oxides, we need to make sure that our subscripts are reduced. We would not want to write this as SN2O4 because our subscripts would not be reduced. So this one would be tin 4 oxide. One more I do want to do for you here is a 3 and a 2 charge. So we have a 3 and we have a 2. Common denominator between them is 6. So we would need 2 plus 3's to get 6, and 3 minus 2's to get the negative 6. So we're going to need 2 of the cations and 3 of the sulfates. The other way to look at this, cross them over. Take the 3, become the subscript on the sulfate. Take the 2, becomes the subscript on the aluminum. So we have Al2 SO43. This means into the variable. So that should get you a good start on this worksheet. The key to understanding nomenclature and formula writing is practice, practice, practice. And that's why you have this packet to do.